Hey guys, this is a quick video on scientific notation, a little bit more information to help you with your assignment today. So first, let's watch why we need to learn scientific notation.
Have you ever wondered how far away the moon, the planet Saturn, or even the nearest star is to us here on Earth? Well, scientists do know. The moon is 240,000 miles away. Saturn, 745 million miles away. The closest star to our solar system, Proxima Centauri, is 25 trillion miles away. I can't even imagine how far that is. Anyway, if scientists had to write out all those zeros every time, they'd run out of room on their notepads or computer screen and waste a lot of time. Luckily, there's an easy way to write out really big or really small numbers called scientific notation without all those zeros. Here's how it works. Really large or really small numbers are written as a product of a number between 1 and 10 and a power of 10. The distance to the moon is rewritten from 240,000 miles to 2.4 times 10 to the 5th miles. The distance to Saturn becomes 7.45 times 10 to the 8th miles. And Proxima Centauri is now 2.5 times 10 to the 13th miles away. That's a lot easier than writing out all those zeros. Like stars and planets, numbers come in all sizes, and we need an easy way to represent them all. And that's why knowing math matters.
Okay. So we watched the video, and now we're going to convert between standard decimal notation and scientific notation. So we're going to go back and forth. Those are what we were going to learn. And here we go. So in the notes that you took a minute ago in the other video, you took a really large number and put it into standard notation. Well, here we're going to take standard scientific notation and put it into standard notation. So let's try that. So we have 7.8 times 10 to the 9th power. So let's write that down. We have 7.8. And then what this means is that there's going to be 9 digits after the decimal. So we have 1 here. So we just need to draw 8 zeros. And we have our number. We can put our commas in. And there we go. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So this number equals to 7,800,000,000. That is why this is so easy. This is so convenient for those scientists, astrologists, astronomers, people in that field. Let's look at another one. Let's see, and I want to show you something else on your calculator. Let me pull mine up here. So let's see, second plus 712. Let's clear it. And I'm going to put this in the calculator and see if it'll come up here. 7.8 times 10. Now, we need to get the exponent up here. So you're going to hit this little hat button, and you can put in a 9. Enter. And there's your number. 1, 2, 3, 4, 5, 6. 7, 8, 9. 9 digits. Okay, so also you can check it in the calculator as well. So let's look at another one. Okay, now we want to put this number into scientific notation. Let's erase this so it's not messy. And let's start drawing. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we know this is going to be 1.4 times 10 to the 8th power. And we can see that the number is between, the decimal comes right before the number that's between, the number in front of the decimals between 1 and 10. So let's check and see if our number is correct. I'm just going to put this in the calculator. .4 times 10 to the 8th power, second hat, whoops. Let me back over that. We just need to hit this. No second, enter. And there's our number. So we know we picked the right answer. We understand. Okay, let's look at another one. Okay, well, this is a big one. 23 digits, not zeros, it's digits. A lot of the kids get mixed up and think it's zeros. Oh, we don't want to do that. We want to erase. So, not sure what I hit there. Anyway, let's do this one. So let's make this into scientific notation. So we're going to start here. We're going to go back 1, 2, 3, 4, 5, 6, 7. Right there, right before the 4. So 4, or 4.0 times 10. This is always the same. It's always going to be times 10. 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7th power. And if we put this on the calculator, we will have 4 times 10 to the 7th power. And there's our number. So you should never miss these because you can do it by hand and then you can check it with your calculator. Let's see if there's any more. Oh yeah. Okay, we can do both of these. And if we were in the classroom, you would be doing these two on your own, but since we're not, you can still do them on your own. I'm just not going to be able to look at them. So let's put this in standard notation. That means the way numbers are written. So I'm going to put 1 point, and there's already 1 0, and we need 5 digits. So I'm going to draw 4 more. Because there needs to be 5 digits. So we know this number should be 100,000. This question is good because it says, is 10.2 times 10 to the 5th power written in scientific notation? If we were together, hopefully some of you would say no. And that is because this needs to move over. The number needs to be between 1 and 10. And 10.2 is more than 10. Let's go to the next one. Okay, this would be your formative, and I would look at that and make sure you understand what we're doing. So we're going to put these numbers in regular number format. So let's do that. We have 3.2 times 10 to the 3rd. So we need to have 3 digits after the decimal. Here's 1, 2, 3. So 3,200 would be our answer. Remember, you can check these in your calculator. And another way to check it is, let's see if I can do this, is 3.2 times 10. Now when you hit this x squared, you can hit it like that, and you can back up over the 2, and you could put a 3. Nope, that won't work. Okay, I couldn't remember if it did or not. So we need to go back here, hit that, hit the little hat button, and then put your 3 in. And there's 3,200. Okay, I'm not going to do these. Let's keep going. That would be your homework in the good old days. Let's see. I want to look at some small numbers and put them into scientific notation quickly. So they're measuring the weight of a butterfly. So we know this number is going to be really small as it has a lot of zeros in front. So we're going to start with the decimal. We're going to count backwards. 1, 2, 3. We can't stop there because 0.7 is not between 1 and 10. We need to stop here. So we have 7 times 10, and there's 4 digits. 1, 2, 3, 4. 10 to the negative 4 power. Let's put that in the calculator and see if that works. So we have 7 times 10, little hat, negative 4. Let's see what we get. Okay, this means 10. So 7 times 10 to the negative 4 power. So that works. Let's see what else we got. Okay, we can do both of these. And I think that might do it. Let's see. Let's erase this so it looks nice. And draw. And here we go. So we have 1.7. And we need to put that in standard notation. And we're talking about an ant. And we can see this is a negative 5 power. So we need to go this way. We need to move 5 digits. 1, 2, 3, 4, 5. Because the number is very small. If we put the zeros in back, it would be like 170,000, and that's not right. An ant doesn't weigh 170,000 pounds. So we can see that we have our 5 digits here, and there's our answer. In this one, they want you to convert it to scientific notation, so we'll do the same. And this is talking about the venom of a bee sting, the grams of the venom. So we know that's small as well. So 1, 2, 3, 4, 5. We have to go here because 5 is between 1 and 10. 5 times 10 to the 1. We went back 1, 2, 3, 4, 5, negative 5 digits. Okay, let's see if there's any more that we should do. Yeah, let's do this. This is how it's going to look on the STAR test. This would be an example of how it looks. So they're going to say, which of the following represents this? So we could put each one in the calculator to see which one works, or we can do it by hand. So I'm going to do it by hand, and then we'll check the calculator. So we need to move back 1, 2, 3 places. So we have 3.28. And we have one of those here and one of those here. And we move back 3 digits. So times 10 to the 3rd power. Here's our answer. And to check that, I'll put it in the calculator. And we have 3.28 times 10 to the 3rd power. 3,280. There's our number. And this last one, let's convert this. And we can see this is a really small number because it has the zeros in the front. And we're going to move back 1, 2, 3, as 1 is between 1.09 is between 1 and 10 times 10 to the negative third power, because we went back 3 spaces. 1, 2, 3, 3 digits. And we can check 1.09 times 10 to the negative third. And there's our number. That's it on scientific notation, guys. If you have any questions, please come see me in the Zoom 11 o'clock meeting. Thank you for watching.